we off the switch 1 and on the switch 2. Okay, so you can see we have other values, and other the value still remains 0.
Yes.
So that's to tell us. Okay, now you can see we are still having the same thing here.
Yes.
The voltage of plane, it is still open circuit. The sending voltage is still 111. The receiving voltage is 110. The sending current is 0. The receiving current is still 0. The power factor 0. So there's no way we have power factor since there's no current flowing in the circuit. So that's
That means I'm no load.
no load, yes.
No load across.
No load, exactly. So that's what the open circuit want us to know, that whenever we have open circuit, the voltage goes to maximum, both at the receiving sending and the receiving end, but the current go to minimum. So we're having 0 current. Okay. So any question? We are still on page 19. On the circuit, you still have the diagram, the same thing. The only difference is that at the where we're supposed to connect the open and where we're supposed to connect our load, it has been short with this wire. Can we see it? So what is telling us that at this point where the load is to be connected, we short it. Okay, and but before we do that, we make sure that we have the supply. Then you short circuit it by putting this cable. That means you have linked to both live and neutral. So if this is my bulb and I put wire here, here and here, and I on the socket, you will have a glow. That bulb will light up. That means we have connected load.
Yes.
But in a situation, I'm not using the bulb. I'm using this cable. If I connect the cable here, then connect the cable here, that's short circuit, because I've connected two lines together as one, and then that's why we have spark. And
Yes.
at short circuit, as you have said, we will have the high current, and that's the principle of the short circuit, that when you short circuit the line, the current will go to maximum.
Yes.
Current will go to maximum. Voltage will
Go to minimum.
go to minimum at the receiving end. Okay, that is the principle of short circuit.
It will cause damage.
It will cause damage, and in order not to cause damage here, that's why we are asked to set this to 110, because if it is up to 220 or 200, you will have the damage on the appliances that we are using. Okay, and if you take note again, it's the same procedure with what we are doing, page 20 now. The same connection with the open and short. The only difference here is this one now. That is this place we are. I thought you are speaking.
She's tired.
This is the short circuit now. So this is just the difference. Okay. Now we will send a note of warning. I think somewhere there, that okay, when we are connecting the short circuit, make sure that at a time, select the switch, page 19. Okay, now there is a warning there, that make sure that's page 20, that do not perform the short circuit test for long time because of high current resistance gets heated. Do not perform the short circuit test for a long time because of high current resistance get heated. What it's saying is that now after we have connected this, that whatever experiment we want to perform on short circuit, we should not let it be long. That's why we're having low voltage, because as it is getting long, because we're having high current, the components used there will be warmed up. When you get to a certain state, it will no longer be warm. It will be heated up, and when you get to size it will melt, whereby it will not be able to absorb. It will not be able to work with the current supplied again, but it is high. So now we on it. So when we now all these are off now. So all these are off. Okay, the switch 1, switch 2, switch 3, and you can see let's switch all on the switch 1. Now these are the value that we have there at the supply end. At the supply end, our don't mind this one. Put 110 is fluctuating. And see, as I'm increasing the voltage here, the current is increasing. Can we see it's increasing?
The sending current, ba?
As I'm increasing this voltage, so the current is increasing. So as I'm reducing it, the current is also reducing. Okay, so we have one. So we have to be careful here. This 110. So when it is 110 now, the current rating of this fuse is 2 amp. So we shouldn't supply any current that will be more than this 2 amp. So as I'm increasing this, when this current gets to 2 amp, it will cut off
The element.
the fuse. And it means that, so they put this here so that it will secure the device. Okay, so now what we notice here is that this at short circuit now. The voltage is at maximum here. Then, but at the receiving end, there's no any voltage. Abi? No any voltage. Okay. No any voltage at the receiving end. Then at the supply current, the current is 1.157 amp, while at the receiving end too is the same thing. So current has go to maximum here at the receiving, but at the open circuit, what was the current here when it was open? When it was open circuit,
The current is 0.
the current is 0, but now it's receiving current but at maximum. Okay, so then we have the supply power, that is V times I, but at the receiving end we will not have any power because voltage is 0 here. Then you also have other parameters. Then you have the power factor here, 0.75. Here we do not have any power factor because of the voltage on it. Okay, now you can see we have another value here. At the power at the supply at the sending end is 131, but no reason. That's the with all them we did this one too. So now when we switch off the switch 2 and we switch on the switch 3, so we can see again the supply voltage is 111, receiving voltage is 0. The supply current is 1.57, while the receiving current is 1.58. That means it has go to maximum.
Okay.
It's telling you that we have short circuit. The power factor is 0.75 at supply end, sending end, while at the receiving end the power factor is 0 because of this no voltage. Okay, so what they want us to know here is that when you are transmitting and then you have not connected to the consumer, it means that the voltage has okay. So what it means that when you have not connected to the consumer, it means that there's no current, because there's no load. So, but after you have, okay, so until you connect to the consumer before you have before you have the current supplied. Now at the so when you have a short circuit, it means it happens in all the circuit, not only transmission line. When you have the short circuit, so short circuit means that the voltage goes to minimum while the current goes to the maximum.
Okay.
And that's when you always have boom.
The more the voltage increase.
The more the voltage increase, because if you look at the voltage is directly proportional to the current. Voltage is directly proportional to the current. So whatever happens to the voltage also happens to the current. When you increase the voltage, the current also increases. When you reduce the voltage, the current also will reduce. But the Ohm's law says that provided the temperature remains constant, that means as you are increasing the voltage, provided that temperature remains constant, and that temperature is talking about the resistance. So that means that nothing will happen if the resistance does not change. It will obey Ohm's law. If the temperature change, that means it will be obeying it, but it will get to a state it will not obey it again.